All right, so we are moving on to our next set of videos. This set of videos is over polynomials. So as we work through all of these videos, the first thing that we'll do is identify what are polynomials, any vocabulary that's associated with them, how might we name them or how might we categorize them, and then move on to the operations such as how do we add, subtract, and multiply polynomials. In this video itself, we're going to be trying to identify polynomials. So I'm going to try and explain to you formally and informally what a polynomial is, and then we're going to try and pick out certain math expressions and identify whether those expressions officially are or are not a polynomial. So let's go ahead and start with our formal definitions over here. Both of these definitions I have pulled from the math textbook that I'm referencing over this class. The first formal definition of a polynomial is a finite sum of terms of the form a times x to the nth power. And the second one says it's an expression of the form and what you see there. Now, once I give you these definitions, I definitely don't expect you to completely understand what polynomials are. These definitions here are very math textbook definitions in my opinion. They don't really explain what polynomials are. They just kind of clarify it for somebody who already has an understanding of them. But if you are new to this and you have no idea what a polynomial is, I don't think that these guys do a very good job of trying to explain it. So I have tried to come up with my own definitions of polynomials. So I've kind of defined it in one of two ways, but hopefully you see how they fit kind of one and the same. So my first definition of a polynomial is a mathematic sentence of nice operations, and I use this word sentence for good reason. Just like we have a sentence in our English language, it has a very formal structure. The beginning of our sentence starts with a capital letter, the end of our sentence ends with punctuation, and it's very particular how things are written in between. And that's the same thing of a polynomial. It has a specific structure. We want it to start a certain way, end a certain way, and we want everything in the middle to follow the format that we have set up for it. Now, the other way I've defined a polynomial is a string of nice mathematical operations. And I use the word string here as opposed to sentence. Now, the reason that I use the word string or even sentence to try and help identify what a polynomial is because I'm trying to get a visual representation for you. Most students are visual students, so I'm trying to get that visual going in your mind. So string or sentence is basically one long statement or one long mathematical expression. Now notice in both of these here that I've used this word nice. Now that is definitely not a formal math definition by any means, but I'm trying to help you figure out what fits in here and what doesn't fit in here. So when I say the word nice mathematical operations, I'm talking about addition, subtraction, multiplication, and exponents, but only the exponents that we'll see are positive exponents. So extremely easy or nice mathematical operations. Examples that are not nice, or I might even be using the word ugly, example of ugly math operations are radicals or roots, absolute value, and fractions. And the reason that I say that these are not nice or again ugly is because these take a little bit more work than what the other operations are. Now there's kind of a trick that goes with it. These ugly operations, they need to be over the variables for it to be considered ugly or not nice in the first place. If those operations are over the numbers in our expression, then that still can be considered a polynomial. Now at this time, I definitely don't expect you to fully understand what a polynomial is, so let's try and work through some examples so hopefully I can clarify some of these questions that you may have at this time. So I have 4 examples here, and in these examples we're trying to identify which of these 4 are a polynomial and which of these 4 are not a polynomial. So think back to kind of my definition here. All of these are kind of a sentence or a string-like structure. It's one long mathematical expression, but we want to refer back to our operations. Our nice operations consist of addition, subtraction, multiplication, or exponents or powers. Just note that the exponents will be positive for it to be a polynomial. And then the ugly or the not nice operations are things such as like radicals, absolute values, fractions per se, and there can be other operations here too. Just remember that with these ugly operations, they can be over numbers, but they cannot be over variables. They cannot be over letters. If they're over letters, that definitely means that it's not a polynomial in the first place. If we have one of those ugly operations over numbers and numbers in itself, then that's okay. So I suggest that you pause the video at this time and just take a wild guess to see if you can clarify which of these are and are not polynomials. So let's just go by example to example. So let's start with example number 1, and let's try and clarify whether that is or isn't a polynomial. So again, it's kind of one string of mathematical operations, and most of our operations are nice. We have addition, we have subtraction, we have multiplication in here, but we also see a not nice operation. We have a division or we have a fraction bar. And since that fraction is over a letter, or since it is over a variable, that tells us immediately that this is not a polynomial. So at this point, we're just trying to pick out if this mathematical expression has any of these ugly operations in it or not. If it does, then we classify it as not a polynomial. If we don't find any ugly operations over the letters or over the variables, then we will claim that it is a polynomial. So moving on to example 2, hopefully you notice first and foremost that it does have an ugly operation. It does have a square root in it, and this square root is over numbers and letters. And since it is over letters, then that again tells us immediately that this is not a polynomial. All right, let's move on to example 3, and again, let's separate out these nice versus ugly operations. I see that it has subtraction, which is okay. It has multiplication, which is okay. It has a positive exponent, which is okay. But the thing that we might worry about here is that it does have a square root involved. Now, a square root is considered an ugly operation if it is over the letters or variables. This square root specifically here is only over a number. So even though I put it in the ugly operation group, since it's over a number, that is okay. So I don't have anything here to tell me that this is not a polynomial. So that tells me that this is a polynomial. And a way to kind of think around this is if you don't want that square root to be in there in the first place, you can get rid of it. You can change that square root of 7, and you can simplify it by typing it in your calculator and figuring out what that square root of 7 actually is. It's a decimal, but that's okay because I didn't identify decimals on either the nice or the ugly list here. So I could write this without the square root, which then just emphasizes that this is a polynomial in the first place. So looking at our last example, again, we have nice operations like multiplication and exponents. We do see this fraction here, but again, this fraction is just over numbers, so it's okay. And I could get rid of that fraction by actually dividing it out. I could take 4/5 and divide it out, and therefore I could rewrite this without a fraction in the first place. And since I can do that, that tells me that this is a polynomial. So hopefully after working through these examples here, that kind of separates out the polynomials versus the non-polynomials. But again, I would still understand if you had some confusion about what an actual polynomial is. And for that reason, let me show you what typical polynomials look like. So I have our formal definitions here, but more importantly, I have these examples down here. I have two examples, and these are what typical polynomials look like. They're a string, or they're a sentence of mathematical operations, and they only have nice operations in them. Notice we have addition, subtraction, multiplication, and positive exponents, but nothing else typically in it. Typically no square roots, no absolute values, no fractions, or anything else of the sort. So hopefully now you can kind of categorize what a typical polynomial looks like. And if you compare each of these examples to this expression here, hopefully you see now that it kind of fits in. Each place that we see these A values, those are the numbers in front of each of the variables that we have here. Then we see that we have x's, and we have those x's there, and then we see that we have the powers involved. And so we have those powers there. So even though the expression of the form with all of those a, x, and n's don't make a whole lot of sense at first, now hopefully when we see specific examples of it, you know what it's trying to explain in the first place. This is where I'm going to stop this video. In the next video, I'm going to be talking more about the sentence format of the polynomial. How should it start? How should it end? What should it look like in between? And along with that, all of the vocabulary words that are associated with a polynomial.